So first we need to determine whether each function is a linear or quadratic. So to identify the quadratic, the linear, and the constant terms. So first, let's simplify. So we have f of x. Since there's a 1 in front, I don't know if you can change it, so x squared plus 5x minus x squared. So if I simplify my like terms and combine my like terms, these end up canceling each other out, becoming 0. So I'm left with 5x. So this, according to our quadratic function, which these are our quadratic, linear, constant, this is my linear term. So that means this function is a linear function. So let's look at our second one. We need to FOIL. So x times 3x is 3x squared. X times a negative 1 is a negative x. Negative 5 times 3x is a negative 15x. And negative 5 times a negative 1 is a positive 5. So now we can combine our like terms. So a negative x and a negative 15x combine to be a negative 16x plus 5. So if we identify each, this is our quadratic term, our linear term, and our constant. So this is a quadratic function. Let's look at our last one. We need to distribute x. So x times x is x squared. X times 3x, or sorry, x times 3 is 3x. There's no like terms to combine. This is our quadratic, this is our linear. So this is a quadratic function. So let's look at graphing a parabola. When we are looking at a parabola can be facing up or it can be facing down. An axis of symmetry is the vertical line which divides our parabola in half. Meaning it's symmetric, so when it cut down, both sides are symmetric to each other. And the vertex, we could have a vertex. We have a down-facing parabola. Here's the vertex. We can have a maximum vertex, or we can have a minimum vertex when it's facing up. So let's look at an example. Let's plot a point at 2, 3. This is going to be my vertex. I'm going to make another point at 0, 0. And 4, 0. Our axis of symmetry is the vertical line, crosses the x-axis, and it's at x equals 2. So let's identify the vertex and the axis of symmetry of our parabola. So the vertex is up here. So we have a vertex at negative 2, positive 4. So here's our vertex. Our axis of symmetry crosses the x-axis, and it's crossing at negative 2. That's our axis of symmetry, which is making these two sides are symmetrical to one another. So let's identify the corresponding points to P and Q. So the corresponding point to P is over here. So the corresponding point to P means we're at a 1, 2, negative 5, negative 2. And our corresponding point to Q is negative 1, 2. So let's look. The table shows data about the wavelength x in meters and the wave speed y in meters per second of deep water ocean waves. Model the data with a quadratic function. So first let's model this function. So let's use our calculators. We want to hit stat, number 1 for edit, and let's clear out our tables. So our x's, we have 3, 5, 7, 8, and my y's, I have 6, 16, 31, and 40. So to models with a quadratic function, you want to hit Stat, Calculate, number 5, Quadratic. So when we write a quadratic function, we have y equals our a, which is 0.589, so we round to 0.59, so 59 hundredths x squared. Our b is 0.335, so we'll round it to 0.34 plus 34 hundredths x. And our c is negative 0.331, so we'll round it to negative 0.33, so minus 33 hundredths. So there's our quadratic model. Now let's use this model to estimate the wave speed of a deep water wave that has a wavelength of 6 meters. And we know wavelength is our x, so that means we want to replace x with 6 and solve. So if we do 6 squared, we have a 36, and 34 hundredths times by 6, we end up with 2 and 4 hundredths. So 59 hundredths times by 36 is 21 and 24 hundredths, plus 2 and 4 hundredths minus 33 hundredths. So when we combine all those together, 21 and 24 hundredths plus 2 and 4 hundredths minus 33 hundredths, we end up with 22 95 hundredths, and that's meters per second.